What is going on, guys? Welcome to this Python tutorial series for intermediates. Episode number 2 today will be about inheritance. So again, it is about object-oriented programming, but this time we're getting a little bit deeper into the material. So we're going to talk about inheritance. What is inheritance? Basically, imagine inheritance to be having a generalized class, and classes that inherit from this class can be more specialized. For example, we could have a class animal, which is pretty generalized, and then we have the class dog, the class cat, the class parrot, for example, and all these classes extend or inherit from the base class, from the parent class, which would be animal, because all of these animals are animals, obviously, but not every animal is a dog, not every animal is a cat, but every dog is an animal, sorry, and every cat is an animal. So we're going to create these class structures where we can have one general class and many different classes that inherit from this class. So let us get into the code. Now let us just continue to work with our person class from the last video. Now person is a very generalized class, like everyone is a person. And if you want to narrow it down and put people into categories, we could just go ahead and define a subclass that inherits from person. For example, something like worker. Not everyone is a worker, so we have unemployed people and so on. So it would be a categorization. And what I could do in Python is, of course, I could just go ahead and define a new worker class completely independent from the person class. So I just do everything again, name, age, height, and an additional value like salary. And then I could just go ahead, ignore that I have the person class, and start defining everything from the beginning, self.name equals name, and so on. Um, but this is not reasonable because worker is just a person. It has all the same elements, attributes, and all the same functions. So it wouldn't be reasonable to do everything again, but it would be reasonable to inherit from the person because it's actually the same thing, but we're just extending the class. So a worker still has a name, an age, and a height. So it's a person basically. And to do that in Python, to say that a worker is just a person, we use parentheses after the class definition, and we pass the parent class, in this case, person, which we want to inherit from. So by saying that here, worker and person in parentheses, I say that the worker is a person and that I can treat it as a person. So instead of assigning everything again, I can use a special method called super. Super is accessing the parent class. So what I can do here is I can just pass the class that I'm working with right now, so worker, and I also pass the object, so self. And then I can just access the init method, so the constructor of my parent class. So by doing this here, I'm just accessing the init function that I already have up here. So I'm not writing everything from scratch. I can call the constructor function from the parent class. And here I can again pass all the values, age, height, and that's it. And of course, for salary, I have to do it again because salary is not something every person has. So self.salary equals salary. And of course, I can just go ahead and define a new function here. For example, calculate yearly salary. And we also have to pass the self here. And then I just return the salary I have. Because it's monthly, I return it times 12 months. Now I can go ahead and define a new worker, work1 equals worker, and then I pass all the values here. So let's say Henry. Henry is 40 years old, 176 centimeters high, and has a salary of $3,000 a month. So I can just print the information and of course also print the yearly salary. So calculate yearly salary. And you'll see that when I run this, you'll notice one thing. First of all, self.salary, sorry. Self.salary. You'll notice one thing, that the print method here, or the str method, the string method, does not print the salary. So in this case, it prints the name, the age, and the height because we're still having a person here, but it does not print our salary. So if we want to change that, we can do something which is called overriding methods that we already have. So basically overriding. And we do that by just overriding. It's not a special thing. We just say def str and pass self here. And by defining the same function, you just override the function that already exists. So I can return, actually I could just make something else here. I can say text equals super and then call the super method here and call this string function. So str of the parent class. And of course, then I can just add to this text the new text, which would be salary and placeholder dot format self dot salary, and then I can return the text. So I think this should work. As you can see, it works. So we have all the values now because we've overwritten the method, and we do this by just defining the same method again. If it already exists, we override it, and that's basically how it works. So here we have the worker, which inherits from the person class. Now, of course, worker is still pretty generalized. So we can even go further and say, okay, give me the class programmer, which is a kind of worker because he works, he has a salary, but he maybe also has a favorite programming language. And we can go much further with that. So we can inherit and inherit again and inherit again. So we can make big structures and trees of inheritance here if you want to even model the reality better. Now, another thing I want to talk about in today's video is operator overloading. And operator overloading is special because not every programming language allows you to do user-defined operator overloading. For example, Java does not allow it and Python does allow it. I think C++ also allows it, and it depends on the programming language, but what operator overloading basically is you can define yourself what happens when you add or apply any operator on two of your objects. For example, if we have two person objects, what shall happen when I add them to each other? So person 1 plus person 2, what should happen? Or person 1 minus person 2. So we can define what happens when we apply operators ourselves. Java does not allow this. In Java, you can now not define that. Now, in the example of persons, it might not make a lot of sense to add two persons to each other or to subtract them from each other because you can, of course, you can define, I don't know, add the two ages and choose the first name or something, but usually it's used in other classes. For example, when we have vectors, if you want to define vectors, it makes kind of sense to define an add operation. So what happens when you add two vectors to each other? Because if you don't know what vectors are, they're just vertical lists in mathematics, which tell you how much you want to go into the x direction, how much you want to go into the y direction, and if it's three-dimensional, also the z direction. But for two-dimensional vectors, we just have the two values for x and y, and we want to know what happens when we add two vectors. When we add two vectors, we add the two x values and the two y values, and we get a new vector. And this is what we want to model in Python right now. And to do that, we have to create a class vector. And this vector, of course, has a constructor self dot x and y. So a vector has an x value and a y value, and we're going to assign that self dot x equals x and self dot y equals y. And now we want to define what happens when we add one vector to another vector, vector 1 to vector 2. And to do that, we use the underscore underscore add underscore underscore method. So like this again. So in this case, we define what happens when I add two vectors. And as a parameter, I get self, of course, and another thing. So I will call it other, you can call it whatever you want, but basically you have two parameters. The first one is the vector itself, the object that you're applying the operation on. And then you have another object that is also part of the operation. So in this case, what we could do is we could just return a new vector with self.x plus other.x and self.y plus other.y. And we can do the same thing with sub for subtraction. Let's just copy that here. Self other. And in this case, of course, we don't add, but we subtract the two values. Now, let's also define a string method here to print some information. Very simple. Just say return x placeholder and y placeholder. I'm typing like a retard right now. Dot format, and then you say self.x and self.y. So this should be fine. Now we create a vector 1, which is a vector with the values, I don't know, 2 and 5. And then we have vector 2, which has the values 6 and 3. And now we can print the two vectors, v1 and print v2. And then we can say, okay, vector 3 equals vector 1 plus vector 2. And then we can print vector 3. So when we do that, you'll see that it works because we're adding 2 to 6 and 5 to 3, and the result is 8, 8. So we're going 8 into the x direction and 8 into the y direction. And of course, I can do the same thing with subtraction here. And I get the difference. So this is how operator overloading basically works. So these are the basics of object-oriented programming in Python. I hope you enjoyed it. From the next video on, we're no longer talking about object-oriented programming in detail. So we're going to use it from time to time, but we're not really going to talk about object-oriented programming concepts that much. So these were the two first videos of this playlist. And in the next video, we're going into other topics. So thank you very much for watching. I hope you enjoyed the video. Hit the like button if you learned something. Ask questions, give feedback in the comment section down below. Of course, subscribe to this channel if you want to see more. And thank you very much for watching. See you in the next video. Bye.